Welcome to my channel. In the class 12 relations and functions part 8, we will see the first sum. Show that the relation R in the set A of points in a plane given by R is equal to PQ, such that distance of point P from the origin is the same as the distance of point Q from the origin is an equivalence relation. Further, show that the set of all points related to a point P not equal to 0, 0 is they circle through P with the origin, etc. First, to prove equivalence relation, it should be reflective, symmetric and transitive. To prove equivalence relation, it should be reflexive, symmetric and transitive. For reflexive, set P, P should belong to R. For reflexive, R is equal to P, P belong to R. It is true because distance of P from origin equal to distance of P from origin. For symmetric, if P, Q belongs to R, then Q, P belongs to R. For symmetric, P, Q belongs to R, then Q, P belongs to R. We know that distance of P and Q from the origin is same. Similarly, distance of Q and P from the origin is same. So it is true. Distance of P and Q from origin is same. Also, distance of Q and P from origin is same. Hence, it is symmetric. For transitive, if P, Q belongs to R, Q, R belongs to Q, S belongs to R, then P, S belongs to R. For transitive, if P, Q belongs to R and Q, S belongs to R, then P, S belongs to R. Since distance of P and Q from the origin are same and distance of Q and S from the origin are same, according to this, then distance of P from Q, S is from the origin is same. Since distance of P and Q from origin is same as distance of QS from the origin distance of P and S from the origin is same. Hence transiting. Now we have to see the next part. Further show that the set of all points related to a point P not equal to 0, 0 is circled through a point P with the origin at the center. P not equal to 0, 0 can be P XY. So its distance is equal to square root of x square plus y square is equal to r. Okay. So take for example Q equal to AB. So its distance from origin equal to square root of a square plus b square. Since distance from the origin of P and Q are same, this is also equal to r. If you take these equations, this can be written as x square plus y square is equal to r square. This can be written as a square plus b square is equal to r square. These, you see, these two are equations of a circle, equations of a circle with origin as center. Hence it is proved. Next sum is show that the relation R defined in the set A of all triangles as R is equal to T1, T2. T1 is similar to T2 is equivalence relation. Consider three right angle triangles, T1 with sides 3, 4, 5, T2 with sides 5, 12, 13 and T3 with sides 6, 8, 10. Which among T1, T2 and T3 are related? First we have to prove equivalence relation for equivalence relation of R is equal to T1, T2. For equivalence relation, it should be reflexive, symmetric and transferring. For equivalence relation, R should be reflexive, symmetric and transitive. For reflexive or T1 comma T1 should belong to R. For reflexive T1 comma T1 belongs to R. Since T1 is similar to itself, it is reflexive. It is true, hence reflexive. For symmetric, if T1 T2 belongs to R, then T2 T1 belongs to R. For symmetric, T1 comma T2 belongs to R, then T2 comma T1 belongs to R. Since T1 and T2 are similar, it belongs to R. Similarly, T2 and T1 are similar, it belongs to R. Since T1 and T2 are similar, T1 comma T2 belongs to R. Since T2 and T1 are similar, T2 comma T1 belongs to R. Hence it is symmetric. For transitive, if T1 comma T2 belongs to R and T2 comma T3 belongs to R, then T1 comma T3 belongs to R. For transitive, if T1 comma T2 belongs to R and T2 comma T3 belongs to R, then T1 comma T3 belongs to R. Since T1 and T2 are similar, since T1 and T2 are similar, T1 comma T2 belongs to R. Since T2 comma T3 belongs to R, since T2 and T3 are similar, T2 comma T3 belongs to R. Hence T1 comma T3 also similar, so T1 comma T3 belongs to R. Hence it is transitive. Next part is consider the three right angle triangles T1 with size 3, 4, 5, T2 with size 5, 12, 13 and T3 with size 6, 8, 10. Which among T1, T2 and T3 are related? T1 is equal to 3, 4, 5. T2 is equal to 5, 12, 13. T3 is equal to 6, 8, 10. It is to be similar. You see, similar means the numbers should be proportional. In T1 and T2, it is not proportional. In T1 and T3, 3 becomes 6, 4 becomes 8, and 5 becomes 10. So T1 and T3 are related. Thank you very much. Hope you would understood the solution to the problem. If we have any doubt, put it in the comment box. We will come up with the doubt clearing video. In the next series, we will continue the further sums of the relations and functions. Thank you very much.